Welcome to CSEGURU. In this session, we will discuss the topic Deque Introduction. There are four variants in queue data structure. One is circular queue, second one is Deque or otherwise called double-ended queue, and third one is priority queue, and fourth one is multiple queue. So already we have discussed a circular queue. Now we will discuss the second variant, Deque. So Deque is a queue data structure in which elements can be inserted or deleted at both the ends. Normally, what do you mean by queue data structure? If you are considering this as the queue data structure in the sense, here there are two pointers we will use in queue data structure, right? One is rear pointer and another one is front pointer. The first element in the queue data structure will be considered as the front pointer and the last element will be pointed by rear. So front and rear are the two pointers we will use in queue data structure. So whenever we want to perform an insertion in the sense, insertion happens at the rear end. This is insertion. Okay. Similarly, if you want to delete it in the sense, deletion happens at the front end. Okay. So insertion happens at the rear end and deletion happens at the front end. If you want to insert a new element, increment the rear pointer by 1, then place the element. Okay. And if you want to delete the element in the sense, increment the front pointer by 1, automatically this position element will be deleted. So these are all the basic concepts in queue data structure. Now, what do you mean by Deque data structure in the sense? It is a list in which elements can be inserted or deleted at both the ends. So, both front end as well as the rear end, you can able to insert as well as delete. There is no restriction like only insertion happens at the rear end and deletion happens at the front end. In both front as well as the rear end, insertion as well as deletion will happen. Okay, that is nothing but Deque data structure. It is otherwise called head-tail linked list or double-ended queue. Double-ended queue, why in the sense both the side we can able to insert as well as delete. Both the operation we can able to perform. There is no restriction at all. And here, insertion or deletion does not happen at the middle. For example, if you are considering this as the Deque data structure in the sense, here insertion and deletion happens at both the ends. So here also you can able to insert. Okay. And here also you can able to delete. Both the operation you can able to perform at both the ends. This front side also you can able to insert. And front side also you can able to delete. But insertion or deletion does not happen at the middle portion. We cannot able to perform any insertion or deletion. And in queue data structure we will use two pointers. One is front pointer and another one is the rear pointer. Front pointer is the position where deletion happens and rear pointer is the position where insertion happens in queue data structure. But here instead of front and rear pointer in Deque data structure we will use left pointer and right pointer. Okay, for example, here this is 10, 20, 50, 100. Likewise, if it is there in the sense, this will be pointed by left pointer. That is the left side. And this will be pointed by right pointer. Okay, and if you want to insert at right in the sense, just increment the right pointer by 1 and place the element. And if you want to insert at left in the sense, just decrement the left pointer by 1 and place the element here. Okay. Right pointer in the sense, increment and place it. Left pointer in the sense, decrement and place it. Okay. And if you want to delete an element in the sense, just increment the left pointer, automatically this position will be deleted. And if you want to delete it right in the sense, just decrement the right pointer, automatically this element will be deleted. Just increment and decrement only we are going to use. And when it reaches the max position and 0th position in the sense, the thing is different for insertion and deletion. That we will discuss later while implementing operations. Okay, so this is nothing but Deque data structure. Both the insertion as well as deletion happens at both the ends. Okay, that is called double-ended queue data structure. And here we are going to use only left pointer and right pointer instead of front and rear pointer. And there are two variants in Deque data structure or double-ended queue data structure. One is input restricted Deque and another one is output restricted Deque. So what do you mean by input restricted Deque in the sense? Here insertion input, that is insertion is restricted. Insertion will be done at only one end at rear end. Rear end in the sense that is the right pointer end, insertion will happen. But deletion will happen at both the ends. Both the left pointer location as well as the right pointer location, we can able to delete the elements. But insertion is restricted here. Only right end only insertion happens. That is the rear end. Similarly, output restricted DQ in the sense, deletion can be done at only one end. That is called left pointer end only deletion will happen. But insertion will happen at both the ends, both left pointer position as well as the right pointer position, you can able to perform insertion. That is output restricted DQ. Input restricted DQ in the sense, here insertion is restricted, that happens at only one end, that is called right pointer end, and deletion happens at both the ends. Output restricted DQ in the sense, deletion is restricted at only one end, that is called the left pointer end, and insertion can happen at both the ends. So here input restricted DQ, how we will implement in the sense, see here, insertion will happen at the right pointer end, insert, okay, but deletion happens at both the ends. Here also you can able to delete and here also you can able to delete. That is called input restricted DQ. In some cases, insertion at only at left end is also possible, that we can able to implement, but generally insertion is restricted to only one end in the sense, that is right pointer end. Similarly, if output restricted DQ in the sense, output will be restricted at only one end, that is the left end, that is the left pointer end, but insertion can happen at both the ends. Both the position, both the pointer position, you can able to insert, but deletion will happen only at the end, that is the left pointer end. So these are all the two variants of DQ. So based on the input restricted DQ and output restricted DQ, what are all the operations we can able to perform? 4 operations we can able to perform. Insert left, insert right, delete left, delete right. So if it is input restricted DQ in the sense, here what are all the operations we need to perform in the sense, insert right, okay, and delete left as well as right. Okay, these 3 operations we have to perform when you are implementing input restricted DQ. Suppose if it is output restricted DQ in the sense, what are all the operations we can able to perform? Deletion we can able to perform only at the left end, and insertion we can able to perform both at the left end as well as at the right end, you can able to perform insertion. Okay, so this is output restricted DQ and this is input restricted DQ. Input restricted DQ only insert right, delete left, delete right, and output restricted DQ operations is delete left, insert right. So these 4 operations we are going to discuss with example. Thank you for watching this video.